My dear friends, welcome to Raja SEKAR classes on applied data science with Python. This is lecture number 77. In this lecture, we will try to understand kurtosis. In my next lecture, that is in lecture number 78, I will discuss how to calculate kurtosis by two different data sets which are downloaded from Kaggle database. In this lecture, we will try to understand theoretical background of kurtosis. Kurtosis is a measure of how often extreme values occurs, and these extreme values can be on either side of the mean. Kurtosis is just a measure of extreme events. There is no positive or negative kurtosis. It is peakedness. Yes, this word is important. It is peakedness of distribution. This is golden point. Of course, there is some peakedness controversy that I will discuss while solving data science problems. This peakedness controversy this lecture may not permit me to discuss the peakedness controversy. Time being, just understand kurtosis is peakedness of distribution. Now, there are three types of kurtosis. First one is just this diagram. You can understand from here. Leptokurtic distribution, mesokurtic distribution. Last one is platokurtic distribution. These three distributions, just compare the shapes so that you can understand. This mesokurtic distribution, is it not just like normal distribution or Gaussian distribution? Anyway, we will try to understand these things in more detailed manner in next slide. Just let me proceed further. Just see this one. What it says, this term, what's the first one? It is leptokurtic means what? What is the meaning of that name itself says? Just see, high and thin. That is leptokurtic. This is this one. This is high and thin. This is known as leptokurtic. Mesokurtic means normal in shape. This one is normal curve. Gaussian distribution, normal distribution curve, isn't it? Now, platykurtic means flat and spread out. Just see, this is platykurtic. This is flat. This is flat, and is it not spread out? Yes, it's spread out. It's really visible. Yes, just read this theory and try to understand these points, high and thin with this particular one, leptokurtic, and normal shape with the mesokurtic, platykurtic. Just try to relate these theoretical points with diagrams so that certainly you can understand. Let me proceed further. Now, how can I describe kurtosis? Let me say like this. Consider a Gaussian or normal distribution. In normal distribution, extreme events are likely to occur. It is not that they are impossible. The kurtosis of a normal Gaussian distribution is equal to 3. This point is very, very important. This you must understand. Anyway, how to calculate I will discuss in next lecture. Just see, this one is golden point. A normal distribution has a kurtosis of 3 and is called mesokurtic. That anyway we discussed in previous slide, isn't it? And typically, when reference the kurtosis of other data, we compare that to the kurtosis of normally distributed data, because that's what is found most often in nature. That's why we used to refer always normal distribution. That's the reason. The data means it is applicable for many real-time examples. Even if you observe some weight data, height data, if you plot it, almost it will fit into the normal distribution. That's what it says. Excess kurtosis is all kurtosis about 3. When you get a value for kurtosis that is above 3, you will see that extreme events more likely to occur than in a normal distribution. Just see this, is it not? Distribution with kurtosis greater than 3. Why 3? Why are we comparing? I already discussed the reason. Why? Because normal distribution kurtosis is 3. It's a distribution. Many real-time applications are following this normal distribution. That's why we used to compare other data sets kurtosis with number 3. If it is greater than 3, that is known as leptokurtic, isn't it? Yes. A value for kurtosis below 3, you will say that extreme events are less likely to occur than in normal distribution. With a very high kurtosis, this means extreme events more likely than in normal distribution. When extreme events are likely, you have to plan for tail risk. I will discuss about tail risk in my future data science problems. Time being, just understand that if your distribution with kurtosis less than 3 is known as platykurtic. These 3 points are very important. Just compare with 3. Just see this one also. Leptokurtic is greater than 3. Normal kurtic means mesokurtic, I can say, is equal to 3. Kurtosis value. Platykurtic is less than 3. Isn't it? These are simple and straightforward. Actually, there is something like tail risk in kurtosis. This class may not permit me to discuss the tail risk, but I can say there is something like consider. Let me briefly say a few words about that tail risk. Consider the 2008 financial crisis. Means I can say like this. The risk models that were applied in 2008 for 2008 financial data incorrectly assumed that markets were normal. In reality, when you are modeling stock market returns, they display excess kurtosis, and this needs to be taken into account. Anyway, you need not bother about these few lines. This tells about the tail risk. That tail risk I will discuss in future classes. Anyway, just see this one, what it says. It's simple. Kurtosis range from 1 to infinity. This is one of the important point. Kurtosis minimum value is 1. Your maximum value is infinity. This is range. It's minimum 1, maximum infinity. As I told you, excess kurtosis is kurtosis minus 3. This already I discussed. What is excess kurtosis? Kurtosis minus 3. For example, what is the range of kurtosis? 1 to infinity. Therefore, what is the range of excess kurtosis? If I take minimum value of kurtosis 1 minus 3, that is minus 2. Means its minimum value is minus 2. If I substitute infinity, your maximum value of kurtosis is infinity. If I substitute here infinity minus 3, infinity. Therefore, its ranges from minus 2 to infinity. This is the range of excess kurtosis. Actually, where can I apply this kurtosis? The sample kurtosis is useful measure of whether there is a problem with outliers in a data set. Larger kurtosis indicates a more serious outlier problem and may lead to the researchers to choose alternative statistical methods. It is useful in identifying, in assessing about outliers in a data set, how outliers plays crucial role in data analysis, in solving data science problems. We will try to discuss in my future classes. In my next class, that is in lecture number 78, we will try to calculate this kurtosis for 2 different data sets. We will discuss few more things in my future lectures that may be controversy of peakedness, that may be tail test. Those things I will discuss. This lecture may not permit me to discuss those things. Certainly we will understand those things in my future lectures. Thank you very much.